What is the difference between speed and velocity? Both seem same, right? But in physics, okay, what is the difference between speed and velocity? Velocity. Both, right? Both seem like a uh, same, right? But when you learn about the difference, okay, basically difference in a physics, in a physics, they have a different both, and in machine learning, they are different action, okay, of velocity and speed of and velocity. So in this video, we will understand what scalar vector or how they are used in math and machine learning as well, and where you to see them and from GPS and self-driving cars and in a GPS, in a self-drive cars, right, and many more things that you will see and seem like that. Okay, so in definition, first we are going with the scalar definition and understand what is a one by one. Okay, definition scalar. Okay, in a scalar, uh, uh, okay, uh, scalar is a quantity that has only magnitude, right? Basically, it's just a number, right? In simple term, okay, understand the example, okay. What is scalar? Scalar is a quantity that has only magnitude, right? In some simple term, the example, that is speed, right? Speed is a 50 kilometer prati hour. That is called a magnitude. Magnitude, right? Similarly, temperature. What is the temperature? Let's 35 degrees Celsius. This also a single quantity, right? Single quantity. So that's the magnitude. That's also magnitude. Similarly, when talk about the one more example is a time 2 hours, right? This also we call the uh, scalar value, right? Similarly, when you talk about the vector, okay, vector. So vector, what is a vector? Basically, a vector both magnitude and direction. Basically vector have both magnitude as well as direction. Okay. In simple term, let's example. Okay. Example of that. So is the velocity. So velocity is a 50 kilometer per hour. Similarly, force is a 10 Newton watts. This is the example of a velocity. Basically, velocity. Okay. Let's one more understanding. One more example. Let's we have car. Okay. A car run okay, a car run with a car run with the 50 kilometer per hour in a east direction. In a east direction, this is called a velocity of example, right? Car run in that direction with the 50 kilometer per hour, 50 kilometer per hour, and simply in a east direction, right? This is the velocity. That's the both. We have both magnitude as well as direction. For okay. For real life examples. So Google Map is the best example of a vector. Okay, Google Maps. Some real world example. Real world example. So in a real world example, Google Map. Google Map basically, right? Your location to direction. Okay. Basically, mm, uh, okay. Google Map your location to direction, right? In a Google Map, you search, you something here, right? And you want to go here. So Google shows some routes that something like that. So it's a both location as well direction. So that's a Google Map. It's the best example of a vector, right? Vector. Similarly, the one more example is a weather forecast, right? Wind. Okay. Another example is a weather forecast. Basically, wind. Wind. It's a vector in which a speed plus direction, right? When a wind also run, so in the wind both have a speed as well as direction. That's a good example. Self-driving car detect vector of other cars, right? Basically, our two okay. In a self-drive car, okay. In a self-drive car, sorry. Second example, we are going with a self-drive car. In a self-drive car, detect the vector, right? Detect the vector of others car, right? To avoid a collision. Basically, when a self-drive car are moving, right? And in that particular case, no, in a self-driver, basically machine trained on a vector that will help to avoid a collision. Avoid a collision. Okay, that is simple concepts. I hope you understand that thing. Okay. So one more thing that is understand the example. Okay, we have a data set. We have a data set. In which data set we have simply IQ and study R, right? And this is simple pass or fail. In which data set we have 90 IQ, work study, 100 IQ, let's 3 hours study, and basically this fail 0, and let's pass with the represent 1. Okay, so this we have data. So in a simple term, we have a that follow vector. Okay, that's both have a vector. Okay, and how to calculate the basically no, in the vector representation, how to calculate the magnitude of that particular vector. Okay, for calculating magnitude, we simply do some representation, right, and understand the concept. So we have that x-axis. And this is x-axis. This is y 0, 1, 2, 3, 4, 5, and 6, right? Similarly, 1, 2, 3, 4, and 5, minus 1, minus 2, minus 3, and minus 4. Similarly, same point, minus 1, minus 2, and let's minus 3. Okay, that's we have point. And let's consider first, not with this example, we have vector v is a 1 comma 2, and similarly we represent x-axis 1 and 2 someone here, right? That's point come here, and simply we want to that's magnitude. Okay, We want to calculate this basically the magnitude. It's mean, this is length of this line, right? Length of this line. So how to calculate? Just simply apply the Pythagoras theorem. Okay, Pythagoras. Okay, see, simply apply the Pythagoras theorem. Let's we have that's the two and that's the one. Okay, so in Pythagoras theorem, simply sorry, in the Pythagoras theorem, we simply perform that task for calculating magnitude. So let's we have that's O, A, and B point. Okay, so we want to calculate OA using the Pythagoras theorem is equal to. So how we calculate under root of AO square plus AB square, right? So what is the OA? OA basically, sorry, not that I write the wrong one. So simple V OB square, right? And OA square. So what is the OB square? OB square is equal to 1 plus just 2 square 4. 4 it is been under root 5. Right? This is the OA. This is the OA. Yeah, call that is the OA is equal to under root 5. It what is it? What it is basically magnitude of that vector, right? Magnitude of that vector. Okay, this is magnitude of that vector. Similarly, we want to we same calculate vector of that is well that is there. Okay, so this is for magnitude and vectors.